Hey there, welcome to part 2 of finding holes, asymptotes, and intercepts of rational functions. We're going to go ahead and go through a couple of examples, give you a practice problem, and then that will do it. All right, so let's go ahead and jump into our example here. F of x is equal to 2x plus 1 over x minus 3, and what we want to go ahead and do is find a hole. So step 1, finding a hole, you have to have a reduced function. Looking at this function, it's already completely reduced. I can't factor it. I can't kind of simplify anything. So I'm done. Now, did I go ahead and reduce anything? Did I cancel anything? And the answer is no, I didn't. So for the whole, we have no common factor. So that means no whole. Very simple. Okay, so we can just say none on that. All right, step 2, vertical asymptote. I go ahead and I take my denominator and I set that equal to 0, and I get x is equal to 3. So there is my vertical asymptote. Very simple. Step 3, horizontal asymptote, the ha. Okay, so I'm going to go ahead and I'm going to take my leading terms. Okay, so 2x over x. And if we reduce this, this gives us, I was going to say 2. It is 2. Okay, so y is equal to 2. That is our horizontal asymptote. All right. Okay, next, 3. What are our 3, 4. Come on, Schwarberg. Okay, 4. So 4 is our zeros. Okay, so I'm going to go ahead and I'm going to set my y value, or f of x, equal to 0. And then I'm going to go ahead and solve. So 2x plus 1 over x minus 3. Remember, I multiply both sides by x minus 3. Essentially, the denominator kind of goes away. Okay, and I have 0 is equal to 2x plus 1. And I just go ahead and I solve. So I subtract 1 on each side. We get negative 1 is equal to 2x. Divide by 2 on both sides. X is equal to negative 1/2. Okay, so that's the 0 at negative 1/2. All right, and then last but not least, let's go ahead and use orange. So for step 5, the Y-intercept. So for the Y-intercept, I go ahead and I just plug in 0 for x. So I have 2 times 0 plus 1 over 0 minus 3 gives us negative 1/3, and we get 0 comma negative 1/3 as our x-intercept. There you have it. Pretty straightforward. Okay. All right. Next example. Here I have f of x is equal to x minus 4 over x squared minus 4x plus 3. And again, the very, very first thing that you want to do is go ahead and simplify this, or reduce after you factor. So this is x minus 3, x minus 1. And you're like, hey, nothing cancels. Okay. Well, nothing cancels. This is my reduced function. So guess what? I have no holes because there's no common factor. Step 2, my vertical asymptotes. So for step 2, I take my denominator, each factor, and I set it equal to 0. So x minus 3, I set that equal to 0. X minus 1, I set that equal to 0. And I get x is equal to 3. X is equal to 1. What? There's 2 vertical asymptotes? There are, and we will graph them. It'll be lots of fun. All right. Step 3, horizontal asymptotes. Okay, so again, I'm going to take my leading terms. Okay, so step 3. My leading terms, x over x squared. And if I reduce, this just gives us 1 over x, which implies y is equal to 0 is our horizontal asymptote. All right. Okay. And at this point, if you remember, we have a horizontal asymptote, y equals 0. Okay. some weird things are going to happen with this one, okay? You can think, hey, y equals 0, my intercepts on my x-axis, there's going to be no zeros, but when you have a double asymptote rational function, some weird things happen. So I still want to go ahead and I still want to do step 4, which is I want to set this equal to 0, okay? And I want to go ahead and I'm going to multiply by both sides by x minus 3, x minus 1. Okay, so same thing, x minus 3, x minus 1. Okay, these cancel, right? And we get 0 is equal to x minus 4. Hey, and then I solve. Okay, so I get x is equal to 4. So I have a 0 at 4. All right. Okay, and when you get the vertical asymptotes, if you have 2 of them, some weird things start to happen, even though you have a horizontal asymptote at y equals 0. Okay. So step 5, last but not least, I'm going to go ahead and I am going to evaluate f of 0. And when I do this, we get 0 minus 4 over 0 minus 3 times 0 minus 1, which is negative 4 over negative 3 times negative 1, which is negative 4 thirds. So we have 0 comma negative 4 thirds. And there you have it. Okay, so those are just kind of 2 examples that are a little bit different. Here is a practice problem. Please pause the video. I want you to go ahead and try this one. All right, hopefully you tried this example. What really might have thrown you off is the after you factor out the denominator, you have x times x plus 6. Okay, so you get no cancellations, no holes, but your vertical asymptote, right? I have this x factor here, so I have to set that equal to 0. So that does give me 2 vertical asymptotes. Okay, your horizontal asymptote, again, is y equals 0. Your 0 will occur at negative 2, and then you will not have a y-intercept. Right, because we're dividing by 0. Okay. Last example before we go. Here's kind of a weird looking example, and you'll see this more next year in calculus, where we have a rational function with a radical in the denominator. So here they're just asking us, okay, what is the vertical asymptote? So, okay, well, if I want to go ahead and find a vertical asymptote, I know I take my denominator and I set it equal to 0. Okay, so I have to solve this. Okay, how do I solve? Well, I'm going to get rid of the square. So I'm going to square both sides. So I get x plus 5 is equal to 0. Okay, and then I can go ahead and subtract 5 over. And we get x is equal to negative 5. So there is our vertical asymptote. X equals negative 5. All right, next they want to know what is the y-intercept. Okay, well, now you're throwing me off because you're messing up with my order. So I need to know, where's a y-intercept? It's here. Okay, so for this one, I have a y value and I know my x value is 0. All right, so I need to know, I want to switch colors. What is, label this step 2. Step 1. Okay, so what's f of 0? I'm just going to evaluate x at 0. So I get 0 squared minus 9 over the square root of 0 plus 5, which gives us negative 9 over the square root of 5. Okay? And normally that would be good enough, but remember, I have a radical in my denominator. I don't want a radical in the denominator, so I have to rationalize the denominator. So I'm going to multiply top and bottom by square root of 5. Okay, and when I do this, we get negative 9 times the square root of 5 over, and the square root of 5 times the square root of 5 is the square root of 25, okay, which gives us negative 9 root 5 over 5. So there is your y-intercept, 0, negative 9 root 5 over 5. And that's your answer. Hey, that is it. All right, I'll catch you next time. Be safe, be easy, be healthy.